Okay, in this video, we are going to identify and verify the values of x and y that simultaneously satisfy two linear functions in the form of y equals mx plus b. So otherwise, we're going to have two equations. We're going to find out where they're equal, just like I've done in other videos. But this time on a graph, and we're going to see where the two, when they're equal, they intersect. And that point is a solution. And a solution means the answer. All right, and it has to be the answer. It has to make both equations equal. I'm going to do this equation-wise and on graph, so you can kind of see both. First, I'm going to do it equation-wise. Since I know y equals x plus 3 and y equals negative 2x minus 4, they're both y equals. Since they're both y equals, that means I could set them both up equal to each other. I can set them both equal to each other. And I'm doing that over here on the side here. And I'll probably do it in a little different color so we can see a little bit. Alright, so I'm going to go ahead and just find x. That's what I'm going to do. So I'm going to add 2x to both sides. I get 3x plus 3 equals negative 4. This becomes a zero pair. I subtract 3 to both sides. I get 3x equals a negative 7 to both sides by 3. X equals, and it's gonna, and I'm gonna estimate, you know, like it's gonna be 2. It's a negative 2, and that's 6 and 1/3. That's where I'm expecting it to intersect for the x-axis. Now, if I want to find out where it intersects for the y, I would plug this back into the other one, you know, the original equations, and get it there. So otherwise, y plus 3, I would put I'd put a negative 7/3 in here to make it easier. You see what I'm saying? And then I would do it that way. Well, I'm not going to. I got this wrong. I'm trying to hurry again. So I say y equals x plus 3, and then I would plug this in for x, and it looks like it'd be 1 and 1/3 for one of them, and the other one I'd put in there and do the exact same thing. All right, so that's how I would do it equation-wise. But if you were to do this by graph, there's really a much easier way to do this. All right, I mean, you could do it the way we just did it here. There's another way. All right, so I'm going to use the colors that are associated with the equation. So I'm going to do black first. All right, the first thing is I know that's my y-intercept. So I'm going to go where there's a 3 on the y-intercept, which is right here. All right, my slope is in front of x, and so I'm thinking rise over run, and it's 1, so that means 1 over 1. So I'm going to go, and it's positive, so I'm going to go up 1 over 1. Up 1 over 1. So I'm just doing this. It's all in it. Make those right triangles like we did before. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I can also, since it's positive, I can go down, which is negative, and to the left, which makes it a negative. Down to the left. Down to the left. And then I can connect my line in this way. Now I'm going to erase my little, oh man. Alright, so basically that's what it kind of looks like. Alright, now that I did that one. Now I'm going to do the red one. Alright, in the red situation is the same way. My y-intercept's negative 4, so I'm going to go down to negative 4, which is right here. That's negative 4. My slope is right here. That means it's a negative 2 over 1. That means rise over run. So I'm going to go down 2 to the right 1. Down 2 to the right 1. Now I could go up 2, but I have to go to the left 1. Up 2 to the left 1. Up 2 to the left 1. Up 2 to the left 1. And I could connect my line this way as well. And if I could connect the dots, it would be great. Let me undo that. Try it again. Well, that's not perfect either. But anyway, that's about where it is. Now, if you remember earlier, I said when I did the million, it was like 2.5 or something like that. Or 2 1/3, that's what it was, 2 1/3. And you can see that it is, the x value is negative 2 1/3. So this right here is my solution. Now, we know that we said earlier that it was negative 7/3, which is 2 1/3, and that looks right. The y value looks like it's about 1 1/3, positive 1 1/3. That's what we got when we did that. So we said 1 1/3. So really, we could say negative 2 1/3 and 1 1/3 is my point of intersection, my solution. All right. This is called a single point solution. And that's how we do this.